In this video I will show how to solve for networks which are having AC components, which are having AC source and resistor, inductor, capacitor, etc. So the first video is about the application of KCL and KVL to AC circuits, or applying network theory to AC circuits. So the network is very simple and it can be given by like this. There is a source, there is a resistance, and so again this is a circuit which I have just formulated, and this circuit has been formulated by me or P Academy itself, and so you'll have to validate. We'll just check after getting the result if everything is correct or not. So this is a circuit which is having two AC sources, having the polarity as shown here. So the first step is to apply the KCL and the KVL, and the question is to find the branch current I1, I2 and I3. So if you are applying the KCL on the node, if you are having this is a node 1 and this is a node 2 of the circuit, then applying the KCL, what you will get is, you will get the current I1 is equal to I2 plus I3, and this is my first equation. Now the second step is to apply the KVL. So when you are applying the KVL to this path, and then you will apply the KVL to this path going in this direction. So the first equation will be minus 100 0 plus 20 I1. If I will use the notation of the small letter, and plus 10 I3 is equal to 0. This is my first equation, and the second equation is (5090), which is a voltage, plus 20 I2 plus minus of 10 I3 is equal to 0. So this equation, my 100 with a voltage with an angle making a phase angle of 0 degree, can be resolved as 100 into cos 0 plus j sin 0. So this will become 100, and my 50 making angle of 90 degree, phase angle of 90 degree, can be written as 50 of cos 90 plus j sin 90. So this will become 50j. So again, putting those values in the equation, it will be minus 100 plus 20 I1 plus 10 I3 is equal to 0, and j50 plus 20 I2 minus 10 I3 is equal to 0. So these are the two sets of equation which I will get. And again, if I will remove the 10 from here, making it in the multiple of 10, Then the second equation can be simplified as j phi plus 2i2 minus I3 is equal to 0. So if again this is my first and the second equation respectively, which has been written. So this is my second equation simplified, and from this I can write my I3 is equal to two I2 plus j phi. So if I will say this is my second equation itself in this case, which has been simplified, and or you can call this the third equation, then I have one equation which I have from KCL, which is my equation 1, or the first equation whichever I wrote, or you can call this the third equation. So is that I1 is equal to I2 plus I3. So this will give me my third equation, and the key is that if you have to substitute this in the first equation. So the first equation can be, again, the 10 can be removed as common, and you will get 2I1 plus I3 is equal to 0. So this is minus 10 plus 2I1, and if you are substituting the I3, it will be 2I2 plus j5 is equal to 0. So, and based on this, you have got I1 is equal to I2 plus I3. So my I1 is equal to I2 plus, if you substitute your I3, it is 2I2 plus j5. So if I am substituting that, minus 10 plus 2 into 3I2 plus j5 plus 2I2 plus j5 is equal to 0. So minus 10 plus 6I2 plus 10j plus 2I2 plus j5 is equal to 0. So it is minus 10 plus 8I2 plus 15j is equal to 0. So my 8I2 is equal to 10 minus 15j. So my I2 is equal to 10 minus 15j divided by 8, which comes up close to 1.25 minus of 1.8j. So I have got my first variable, which is I2, which is equal to 1.25 minus 1.8 of j. Now if I am substituting this same thing in this equation, I will get my I1. which comes out close to this is the value of I3. This I will get the I1, and if I will substitute it here in the equation third, so if I say that this is my equation fourth and this is what I got is my equation 5, which is one of my answers, then my I1, if I'm substituting it here, then it will come close to my I3 can be found out as 2 into 1.25 minus 1.8j plus j5, which is equal to 5 minus 3.6j plus j5, which is equal to, or 2.5 into, which is equal to 2.5 plus j of 1.4. So this is how I found my I3 is equal to 2.5 plus j of 1.4, and if I am substituting here, I will get the value of I1, which is equal to I2, which is equal to 1.25 minus 1.8j plus 2 into, or it is 3 into 1.25 minus 1.8j plus j5. So which comes close to my I1 being equal to 3.75 minus of 3.3 into 1.8. 3 into 1.8 is 5.4 minus of j 5.4 plus j of 5, which is equal to 3.75 minus 0.4j. So this is my I1. So in this way I got my solutions, which I can write here. So this is my I2, this is my I3, and this is my I1, which I got. And you can check if it is correct by putting it in this equation or any of these equations to see if it equates to 0, to just validate and see if whatever you have found out is correct or not. So if I am just checking that, what I will get is minus, if I am putting it in the first equation which I got, the equation minus 10 into minus 10 plus 2i1 plus I3 is equal to 0. So my I1 was equal to 3.75 minus 0.4j, and my I3 was equal to 2.5 plus 1.4j. So minus 10 plus 2 into 3.75 minus 0.4j plus 2.5 plus 1.4j, or it is 2.45 plus 1.4j, which is equal to minus 10 plus 7.5 minus 1.4j plus 2.5 plus 1.4j, which is equal to 0. So this satisfies the first equation. So it's possible to check that whatever I have found is correct or not. So I have solved this problem by using substitution, and it's possible to solve the same question by using Cramer's method. So this has been validated as the correct answer for the solution.